In this video we start looking at measures of spread. The easiest and quickest measure of spread to calculate is the range of a set of data, and that is simply the difference between the maximum data value obtained and the minimum data value obtained. So the range is the maximum value minus the minimum value. For small sets of data or large sets of data that have been sorted into size order, this is easy to determine by inspection. For larger sets of raw data which has not been grouped or sorted, then a spreadsheet can be used to find the maximum and minimum values quickly, and the range can then be deduced. For data that has been summarized into groups, which means that some information will have been lost, then an estimate of the range can be obtained by calculating the upper limit of the last group minus the lower limit of the first group. And this will always give us an overestimate of the value of the range. Although the range is easy to calculate, it has got very limited use in statistics because it's totally determined by the extreme values, which means it can be misleading. Look at these three graphs. These three frequency bar graphs of distributions which take integer values. In each case, the greatest value of the distribution is 6, the least value of the distribution is 2, so in each case, each distribution has got a range of 4. However, most of the observations in the first distribution occur in the centre, in fact at the mean. In the second distribution, there's more spread than there is in the first distribution. And in the third distribution, almost all of the values, the data values, occur at extremities. So really, any decent measure of spread is going to give distribution 1 a much smaller measure of spread than distribution 2, and distribution 2 will have a much smaller measure of spread than distribution 3. So, a satisfactory measure of spread will give a small value for distribution 1, a larger value for distribution 2, and a much larger value for distribution 3. Range, therefore, is not a satisfactory measure of spread, since it's totally determined by the extreme observations. The interquartile range is much more satisfactory, and you'll have met that idea at GCSE. So Q1, or the lower quartile, is a data value which is a quarter of the way through the list of observations when they are sorted into ascending order. Q2 is another name for the median, and Q3, the third quartile or the upper quartile, is the data value which is 3/4 of the way through the list of observations when they are sorted into ascending order. The interquartile range then is the difference between Q3 and Q1. So the interquartile range is Q3 take away Q1. If we just have a list of n observations that have been sorted into ascending order, then Q1 will be a quarter of the times n plus 1 observation, and Q3 will be 3/4 of n plus 1 observation. For data consisting of n observations that have been in summarized group form, then Q1 and Q3 should be determined from the cumulative frequency graph using a quarter n and 3/4 n respectively. So let's look at this in the case of a couple of examples. If we've got the set of data 3, 5, 7, 7, 8, 8, 8, 9, 10, 10, 11, 15, 17, 20, 32, 45, 52, then we've got 17 pieces of data. So Q1 is going to be a quarter of 17 plus 1, which is 4.5. So Q1 is the 4.5th observation. So what we do is we take the average of the 4th and the 5th observations. So the 4th and the 5th observations are 7 and 8. So we've got Q1 is 7 plus 8 over 2, which is 7.5. Q2 is the median. So that's a half of 17 plus 1. So that is the 9th observation. And the 9th observation is 10. So the median is 10. And Q3 is 3/4 of n plus 1. So 3/4 of n plus 1 gives me 13.5. So I need the 13.5th observation. 13.5th observation, then clearly I'm going to take the 13th observation and the 14th observation, which are 17 and 20, and take the average of those two. So Q3 is 18.5. So the interquartile range for this set of data is 18.5, take away 7.5, which is 11. For small sets of ungrouped discrete data, the values of Q1 and Q3 can also be found using your calculator. So, if we've got the size of the RAM of each of the 100 laptops as shown in the table here, then we've already seen that we can input the data onto our calculator and obtain the 3 summary screens, from which we can read off that the lower quartile is 4 gigabytes, the median is 8 gigabytes, and the upper quartile is 16 gigabytes. So that we can write down that the median is 8 gigabytes and the interquartile range is 16 take away 4, which is 12 gigabytes. For data that has clearly been summarized by a grouping process, the interquartile range can be found using a cumulative frequency graph. So here's the cumulative frequency graph for the prices of the 100 laptops that we've been considering. If we want to find the lower quartile, then we need the price of the laptop, which is a quarter of the way through the 100 laptops, so that's the 25th laptop, and we can find that by finding 25 on the cumulative frequency axis, going across to the graph and then down to the price. So we've got the lower quartile is approximately £830. Similarly, for the upper quartile, that's 3/4 of the way through the distribution, and 3/4 of 100 is 75. We start at 75 on the cumulative frequency graph, on the cumulative frequency axis, go across to the graph and down, and obtain a value for the upper quartile of approximately £1,560. Putting the two pieces of information together, we can now say that the interquartile range is 1,560, take away 830, so about £730. As an exercise, just pause the video at this stage and look to see what happens if you use your calculator to obtain the interquartile range for the distribution of mid-marks of the previous example. When you've done that, think about the question at the end of this page and then start the video again. The interquartile range tells us the spread of the middle half of the distribution. This has the advantage that it's not greatly affected by the extreme or exceptional values. On the other hand, it does mean that even quite large changes to the extreme values will make little, if any, change to the interquartile range. Now again, at this stage, I'd like you just to pause the video briefly and just calculate the range and the interquartile range for each of the following sets of observations. When you've done that, start the video again, please. Okay, so let's go back to that data set that we had of 17 different values. If we were to draw a standard box and whisker plot for this set of data, then we know the minimum value is 3, so the whisker would go out to 3. The box then would go from 7.5, the lower quartile, up to the upper quartile, which is 18.5, with a line across it where the median is at 10, and then the whisker will go out to the maximum value of 52. So let's see that in action. We've got start off with the minimum value of 3, and the maximum value is out at 52. We've then got the box will go from 7.5 with the median then at 10, and the upper quartile is at 18.5. So there's the box for us, and then we've got the whiskers going down to 3 and up to 52. From the box and whisker plot, we can see that a quarter of the observations lie between the minimum point and the lower quartile, so that's between 3 and 7.5. Another quarter of the observations lie between the lower quartile and the median, 7.5 and 10. A quarter of the observations are going to lie between the median and the upper quartile, so that's between 10 and 18.5. And the final quarter of the observations lie between 18.5 and 52, so that's between the upper quartile and the maximum. Now we're going to refine the idea of box and whisker plots a little bit to incorporate the idea of outliers. So, before we can mention outliers, I'm going to mention lower fences and upper fences for a distribution. The lower fence for a distribution is the value of the lower quartile take away 1.5 times the interquartile range. And the upper fence for a distribution is the value of the upper quartile plus 1.5 times the interquartile range. Any observation that is less than the lower fence or greater than the upper fence is defined to be an outlier. So if we consider our set of data again that we've been looking at recently, we know that the minimum value is 3, the lower quartile is 7.5, the median is 10, the upper quartile is 18.5, the maximum value is 52, and the interquartile range is 11. So we have the lower fence is 7.5 take away 1.5 times 11, which is minus 16. And the upper fence is the upper quartile plus 1.5 times the interquartile range, so that's at 18.5 plus 1.5 times 11, which is 35. Now we can certainly say straight away there are no outliers at the lower end of the distribution. There are no values that are less than minus 16 in our distribution. But on the other hand, the observations 45 and 52 are both greater than the upper fence of 35. So the observations 45 and 52 are outliers of the distribution. In our refined box and whisker plot, we draw the box in the same way as before. If there are no outliers on a tail, then the whisker goes to the extreme observation. But if there are outliers on a tail, then the whisker only goes as far as the fence, and the outliers are shown as individual points. So let's see what our refined box and whisker plot will look like in this case. So first of all, we have a minimum of 3. There are no outliers at the bottom end of the distribution, so we put in the line at 3. At the upper end, the upper fence was 35, and there were values above that which are outliers. So we're going to mark in the upper fence at 35. We can now put the box in as usual and link the box up to the markers we've already put in. So that represents all of the distribution except the 2 outliers. And we now mark the 2 outliers as individual points. So we've got an outlier at 45 and we've got another one at 52. For the prices of the laptops, we had Q1 was $830, Q3 was £1,560, and the Interquartile Range was £730. So the lower fence, which is Q1, take away 1.5 times the Interquartile Range, is going to be 830, take away 1.5 times 730, which gives us minus 265. There are clearly no laptops costing less than minus £265. So there are no outliers at the left-hand end of the distribution. The upper fence is the upper quartile plus 1.5 times the interquartile range. So that is 1,560 plus 1.5 times 730, which gives us a figure of £2,655. And it is clear, again, from the table, from the graph, that there are no laptops in this survey that cost more than £2,655. So there are no outliers at the top end. So we've got the lower fence is less than 300, which is the minimum price of the laptops. The upper fence was bigger than 2,300, which is the maximum price of any of the laptops. So there are no outliers in this sample of laptops. Go back now to the example of the RAM, okay, and see whether you can answer the question, does the distribution of RAM of these laptops have any outliers? And once you've done that, you have actually finished this video.